All right, Chapter 1 review. Tomorrow is the test. So let's go through this together. First of all, let's go ahead and list some natural numbers. Well, the natural numbers are the numbers like 1, 2, 3, 4, 5, dot, dot, dot. Even though it says 5, I'm going to list all of them. So natural numbers are not 0, and they're not negatives. Whole numbers just include 0. Whole numbers are all of the natural numbers except for you have 0. 0, 1, 2, 3, 4. There's at least 5 of them. Integers are going to be positive or negative whole numbers. So they're the positive, negative ones. So as an example, I could have a set of like negative 2, negative 1, 0, 1, 2, and any of the others. As long as it's not decimals or fractions, integers are going to be your positive and negative whole numbers. Rational numbers. Rational numbers can be any numbers that happen to be fractions. So one example is just a fraction. I don't know, let's say 4/5. Let's say another rational number might be 0.6, because that would be a fraction. You can make that a fraction. You can make 1.3. You can make 0.3 repeating, because that could be a fraction, right? You can make 2 and 1/2. As long as it can be made into a fraction. So decimals and fractions are going to be rational numbers as long as they're not weird decimals. Now, what are the weird decimals? Those are irrational numbers. So an irrational number would be something like this, square root of 2. It's like 1.41 blah blah blah. Square root of 3. Okay, that would be an irrational number. We got that special number pi. There's even that weird number e. There's a number e that we'll learn about when we get later on in the class. I need 5, so how about another square root number? How about maybe the square root of 8? That would be another irrational number. Irrational numbers are numbers that have decimals that don't repeat and don't terminate. They're like pi. How am I doing? Good? Okay, number 6. Let's graph this set. So to graph this set, what I need to do is I'll put negative 4. I'll put 7. I'll put 8. I don't really care if you guys put all the numbers in between. Sometimes it's nice to have 0, but you certainly need to have these numbers right in there, okay? So what I'm going to do is at negative 4, I'm going to put a solid dot because of the equal sign. So I'll go to negative 4, I'll put a solid dot, okay? At 7, I'm going to do an open circle because it doesn't include 7. And at 8, again, I'll put an open circle. Okay, so at least I've got all of my numbers highlighted, and then I'm going to figure out where I want to graph, okay? So if I read this carefully, and read x first, if I cover up the 7 and read x first, it really says x is greater than or equal to negative 4. Well, greater than would be going this way. But then it says x is less than 7. So really, I'm going to shade in between negative 4 and 7. Or, so that's part of my shading, then I'm going to hop up to the 8 and do the rest shading. X is greater than 8. Well, that would be all of this. Greater than 9, 10, 11, all the numbers greater. So then I'm just going to make that one a little bit darker and heavier than all the rest. Okay. Number 7. F of 0 just means plug in 0. So I'm going to go, all right, F of 0 is equal to 2 times 0 squared minus 4 times 0 plus 5. So I'm just plugging 0 in for the x's. That's all I did. So it's like 2 times 0 minus 0 plus 5. It's just going to be 5. Now, one of the things that I'm okay with, and I'll show you, is you can actually use your calculator too. If you want to, I mean, you can put this in your calculator just like this. You can go 2 parentheses 0 squared minus 4 parentheses 0 plus 5. So you can actually put the whole thing in my calculator, right? And let the calculator do the work. Let me slide up so you can see that. So I just put the whole thing in the calculator. Just plugged it in. And I can do the same thing with the negative 2. And I'll show that in a second, all right? So f of negative 2, it's the same thing. We're just going to plug negative 2 in for the x. So we'll go f of negative 2 is equal to 2 times negative 2 squared minus 4 times negative 2 plus 5, right? And then if you use your calculator, it's actually pretty easy. You can do the math. You can go 2 times 4 plus 8 plus 5, 8 plus 8 plus 5, 16, 21. But let's say you just use the calculator. 2 parentheses negative 2 squared, subtract 4 parentheses negative 2 plus 5. Okay, so you can let the calculator do the work for you. And I'm okay with letting you guys use the calculator because if you make you may know what you're doing, you might plug it in right and then make a dumb mistake, right? With the calculator, you're not going to make a dumb mistake. 21. Okay, go ahead either way. If you want to do it by hand and evaluate it, that's fine. If you want to use a calculator tomorrow, that's fine also, okay? All right, square roots. 5. Now, 48 can be broken down in a lot of ways. 4 and 12 is not bad. 6 and 8 is not very good. 6 and 8 because there's no square to 6, or there's no square to 8, right? But the best one is 16 times 3. Now, if you don't remember that, that's fine. You can still go 4 and 12. And you got to break down the 12, right? But 16 and 3 is faster. Square root of 16 is 4. Now, everybody listen. Nobody's going to make this mistake. You see this number 4? It is a 4. Don't take the square root of it. Because a lot of kids will say, oh, 4, square root of 4 is 2. There's no square root. It's just 4. So you get 20 square root of 3. That's a pretty common mistake. Kids see 4. They'll take the square root of 4 and get 2. But there's no square root in there, is there? It's just a 4. All right, 9. Let's multiply first. 12 square roots of 12. The 12 on the outside is a regular number. It's a regular old whole number 12. I leave it alone. But the square root of 12 I can break down. What 2 numbers should I use?
6 and 2.
No, I don't like 6 and 2.
3 and 4.
I like 3 and 4. In fact, I'll write it as 4 and 3. But yes. But I'll write it as 4 and 3 because, and Dylan, the reason I won't use 6 and 2 is because there's not a good square root of 2 and there's not a good square root of 6, right? But 4 definitely. The square root of 4 is 2. 12 times 2 is 24. How's that? Okay, 10. So what I'm going to do with my exponents is take half. I'll take half my exponents, but I still have to break down the 32, okay? So 32 can be a lot of different things, but what's a really good combination for 32? 8 and 4 is okay. There's a better combination. 8 and 4 is not wrong.
16 and 2.
16 and 2 is better because it just gets you there faster. And then what I'm going to do is make this an x2 and a y6. I took half the exponents, okay? Square root of 16 is 4, right? Boom. And now I still have the x2 and the y6. They've already been done, so I'm going to put those next to the 4, x2, y6, because I took the square root of that, so I've got 4x squared y6, and then we're still left with the square root of 2. Alright, 11. Okay, in 11, what I'm going to do is rewrite it as 2 separate square roots, okay? Square root of 25 over the square root of 3. Now I like the number 25 because that's a good one, right? Square root of 25 is just plain old 5 over the square root of 3. Now, I'm going to rewrite that down here because I've got to do some more work. So 5 over the square root of 3. So here's the problem. You can't have a square root in the denominator. That's one of the rules. So it's a problem. So we fix the problem with the problem. Remember that? We fix the problem with the problem. So I'm going to multiply top and bottom by the square root of 3 over the square root of 3. I'm going to wind up with 5 square root of 3 over the square root of 9. I still have a square root at the bottom, but I know what the square root of 9 is, right? Take the square root of 9, and I get 5 square root of 3 over 3. Do not cancel 3's. This is not a 3. Of course it's a 3, Mr. Davis. This is not a 3. This is 1.73 blah, 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 blah. Don't cancel 3's because this is not a 3. It's a 1.7320 blah, 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 okay? That's your answer. We're getting good at this, aren't we? Right, Abby? Number 12. Okay, two ways to do it. You can write this expression 5 times. But I'm not going to do it that way. It takes too long. I'm going to go 2 to the 5th, and then I'm going to multiply my exponents. I'm going to get x to the negative 15 and a y to the 10th. Now in the last quiz, too many of you left it here. If it's a negative exponent, we just need to make it positive by moving it. So I'm going to move the x to the negative 15 down and make it x to the positive 15, okay? So that came down. 2 to the 5th. 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. 2 to the 5th power is 32. Now your calculator can also do it. What is 2 to the 5th power? Wait, no, 32, huh? Amazing. And then the y to the 10 has to stay up on top. There it is. So we want positive exponents, okay? 13. We're going to make it a 12. X to the 2 and a y to the negative 1. So I multiplied the coefficients, the big numbers, and I added the exponents, okay? But again, we want positive exponents, so let's bring the y to the 1 down. And we'll have the 12x squared left on top. How are we doing? Not right now because it might unplug. Yeah. Okay, but I'll try and, yeah. Okay, 14. First of all, let's look at the big numbers, okay? Let's look at the big numbers. 12 divided by 6 is 2. You okay with that? Let's look at the big numbers. 12 divided by 6 is 2. And then I'm going to bring the x to the 3 up, which is going to make an x to the 3, y to the 4th. And then I'm going to switch places with both of these because I'm going to take the y to the negative 5 down and the y to the negative 2 up. Because if it's a negative exponent, it needs to be moved, okay? So, oh, that should be an x. No, that's, hold on, I'm making a mistake here. That's an x, sorry. I got distracted. So this comes up y2, and this comes down y5. Now, you can also do it another way. Jackie, you're probably going to go 4 minus a minus 3, aren't you? Which is great. That's the way I do it too. And you're going to go negative 5 minus minus 2, right? Which is great. Okay, we're going to get the same answer. I like the way you do it, by the way. Okay. Let's see what I get. So then I've got a 2 on top. I'm going to have an x to the 7 because I combine those. 2 of these y's will cancel 2 of these y's. I'll get a y to the 3rd. That's that. What Jackie does, she just subtracts exponents. She's going to go 4 minus a minus 3, which makes a 7. She's going to go negative 5 minus minus 2, which makes a negative 3, okay? Okay, ready to turn the page? So far, so good? Not too bad? All right, find the domain. So the domain is all x values, and all x values happen to be from here at negative 3 to here at 6. Okay, I think that's 6. 1, 2, 3, 4, 5, 6. Yeah. So all the x values are from negative 3 to 6. So my domain is going to be from negative 3 to 6, but it doesn't include negative 3, right? So I'm going to go parentheses, negative 3, comma, 6, bracket. Okay. The range is going to be from the lowest value, which is at negative 3, and it does touch. There's no open circle. Negative 3 all the way up to positive 3, and it does touch, okay? This is an open circle, sure, but it keeps going up, right? So it goes from negative 3 up to positive 3, inclusive, all right? That's my range. All my possible y values are between here and here, okay? All right, 16. I'm going to get a piece of graph paper. And if you need graph paper, here it is. So if I'm going to graph 16, I need to know what the parent function looks like. Well, I know what the parent function is. The parent function is a parabola. So here's what I know about the parent function. It's an x squared. So I'm going to go 0, 0, 1, 1, 2, 1, 2, 3, 4, because I'm squaring it. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going off on paper, but and over here and here, okay? So here's my parent function. Of course, we had that yesterday in our notes, right? Okay, that's my parent function, but what I want to do on A is I want to move this parent function. So what I'm going to do on A is I'm going to move it to the left 4. Because I go the opposite direction. So I'm going to go back 4 and I'm going to go up 3. So I'm going to go back 4, up 3. So let's take the vertex and let's move the vertex left 4 and up 3. So let's do A. So I'll go ahead and put this in here. So I take my vertex, take it back 1, 2, 3, 4 and up 1, 2, 3. 1, 2, 3, 4, up 1, 2, 3. So I took this point here, this vertex, and put it right there. Okay, just shifted it back 4, up 3. And then I'm just going to put my parabola in from there. So I'll put my parabola by squaring numbers. I'm going to square numbers because it's x squared. 1 squared is 1, 2 squared is 1, 2, 3, 4. 3 squared is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a line of symmetry here in the middle, which basically you're going to flip over, right? So then the other points would be here, here, and here, right? It's just reflected, okay? Okay, how's that? Okay, you guys ready for B? So B with this negative, I'm just going to reflect over the x-axis, all right? So I'm going to take my parent function, I'm just going to pop it down here. I'm just going to take it, fold it down. So I'm just going to flip it over. So it's going to be upside down, right? So for B is going to look like this. 0, 0. But instead of going 1, 1, I'm going to go 1, down 1, 2, 4. I'm just going to go down 4. So I'm going to go down 1, 2, 3, 4. And of course it's symmetrical. There it is. There's B. How am I doing? Okay. C. I've got on C 3 times f of x. All right. So it's got to be 3 times as tall. It's going to be 3 times as tall because of the 3. So, all right, I'm going to make a tall graph. Let's see if I can squeeze it in here. Super tall graph. All right. All right, I'm going to go way down here because I need a super tall graph, okay? So, 0, 0 is still 0 because a height of 0 times 3. 0 times 3 is still 0. But instead of going 1, 1, I'm going to go 1, 1, 2, 3 because it's going to be twice or 3 times as tall. 2, 4, I'm not going to go 2, 4, I'm going to go 2, 12 because 1, 2, 3, 4 would be normal, but I'm going to go 3 times as high. 4, 5, 6, 7, 8, 9, 10, 11, 12. And now I won't even do the 3s because it'll be off the paper, right? It's going to be way too tall. I'm going to put the other points on the other side because it's symmetrical. So it's super skinny, but it's just actually 3 times as tall. Okay. Not bad. You guys can do this tomorrow? All right, let's, guys, are you good, Ollie? You got it? Everybody have it? So I went 1, 3, 2, 12. Okay. All right. Here comes easy stuff. Okay, A. Is that a function, yes or no?
No,
Why do you say no? You're right. You're correct. Why do you say no?
just because like there's 2 2's.
Yeah, the 2's paired up to a 1, and the 2's paired up to 2. You can't have that. You can't have 2 having 2 different y values, right? So no is correct. Nice job, Megan. Is B a function?
Yes,
How come?
because it's still possible.
It'll pass that vertical line test, right? You'll never hit the graph in more than one place, so there are not 2 y values for any particular x value, okay? C, is that a function?
Yes.
Yeah, same reason, right? no matter how you draw your vertical line, you'll never hit 2 y's. Now there's points lined up this way, but we don't care about that. It's just called the vertical line test, right? Every x has one unique y, right? So that's a yes. Okay. All right, 17. There are 2 ways to do 17, and the book really tries their best to make you do it the hard way, but doggone it, why don't you just use a calculator, honestly? If you just went parentheses, 4.1 times 10 to the power of 5 times a 3.8 times 10 to the power of 6. Okay, you guys see it in my calculator? Just let the calculator do the work. Then we have to know how to interpret the answer. So if we push enter, if you put 1.55 E12, I'll mark it wrong. I will mark it wrong, okay? I promise, because it says scientific notation. The calculator does not know how to write it in scientific notation, but we do. So we're going to write it as a 1.558 times 10 to the 12. Because the calculator won't write the times 10. It just writes the E, which means times 10, okay? And 18. Same thing, we could just divide it by hand, or we can go straight to parentheses, 3.6 times 10 to the power of 4, divided by parentheses, 6 times 10 to the power of 12, right? So I get 6e negative 9. That's kind of the answer. We just have to write it the right way. So it really means 6 times 10 to the negative 9. Because that's what that e means, okay? Alright, I have a little homework assignment for you to do. Let me stop the record button.